Thank you and hello everyone. Nowadays, the software is rarely built only out of custom code. It's usually dependent on some third-party API services, some other components, some open source libraries. All of these dependencies together create your supply chain. Today, I'd like to talk about the supply chain security, especially from the Go perspective. 7 years ago, Go team decided to introduce Go modules. Back before then, the module management in a Go was a Wild West. A lot of third-party tools that try to manage the dependencies, and a lot of them failed, a lot of them were good, but then Go team came and unified everything. I believe that everyone here that is interested in Go saw Go mod file at least once in their lives. It's a pretty simple file, which can contain a lot of directives, but these are the most important ones when it comes to managing dependencies. First line is usually the name of the module. It's your application or your library, which is then followed by the Go version. Then there is one or more require blocks that marks all of the dependencies in your software. It's not only the direct dependencies that are used in your source code, it's also their dependencies, which are called indirect or transitive, and their dependencies and their dependencies and so on, until the full dependency tree is resolved. What we need to know about the Go mod file, that it is not usually managed by hand. There are only two Go commands that actually manipulate the dependencies, and those are go get and go mod tidy. All of the other module over commands just read the Go mod file. Whenever you try to run or build your code, those commands look at the Go mod file, and whenever is something missing, the command will fail. So you are covered from anything missing, and you are sure that only the modules that are in your Go mod files, which was reviewed, are used in your code base. As you have seen, there are no version constraints. You cannot use version ranges. You cannot use like only version 2 of the software. You cannot use latest. Whenever you try to use this, the Go will resolve them to some particular semantic version. So there is no way like someone can push an update and break your code, because Go makes sure that you are using only one particular version of your software, of your dependency. This applies both for direct and indirect dependencies. As I said, Go crawls through all the dependencies and their dependencies and builds a Go mod file and the dependency tree. What is good to know, that unlike in some other languages, Go has no concept of pre-install or post-install hooks. So whenever you download dependencies or build your code, you don't have to worry about running a malicious code on your device. And then, if you don't use code in your repository or in your software, you don't have to worry about it. It has absolutely no effect on the security. Even if your module has multiple packages and you use only one of them, that is the one you should only care about. The others are irrelevant. Now, Go team designed the Go modules to be decentralized. There is no central registry where you need to register your module, where you need to push it. You just need to host your module on like GitHub or any other version control system, and Go takes care that all of the consumers are able to get that. Most of the modules are stored in version control systems, which comes with a couple of downsides. Not all of them are enterprise grade, that they can be custom hosted, and they vary in speed, reliability, and mostly availability. The problem with directly accessing version control system is that when you try to resolve the dependency tree, which means going first through your code base, then through your dependencies, then through their dependencies, and so on, you would need to check out the repository with the particular version each time you want to resolve another transitive dependency. That would result a lot of checkouts, a lot of data, a lot of traffic, and mostly a lot of waiting time. When you become dependent on the version control system, the developer has the ultimate power to shut down the dependency. So they can easily come and delete the repository. The other thing that applies is that the developer can be malicious, and once you get used to their dependency, they can push in a compromised code that can compromise your software. And I almost forgot, you have to deal with version control tools, which means that each time you want to check out the Git repository, you have to run git binary, which is another attack surface that can compromise your supply chain. After first version of Go modules was introduced, Go team became aware of all of these shortcomings. And they came with pretty clever solutions, which helps to cover your software and supply chain. First, they introduced module mirrors, which you may know as a Go proxy. It's a unified interface that allows you to interact with modules. So instead of reaching out to individual repositories, there is one single API, which consists only of 5 endpoints. First of them is to list all of the versions of each module. The second endpoint is to get the details for each version. Third one is to resolve the latest version. Fourth one is to download GoMod file. And fifth is to download the whole zip file of the whole repository. This allows you to use a simple API instead of VCS tools. So there is no way that you will run a compromised Git binary or Git binary with known vulnerability. It also serves as a cache. So when anyone downloads the dependency through the Go proxy, it gets stored there forever. Which means that whenever someone decides to delete the directory or change it, you are still able to access the downloaded version, you are still able to build your code, and you don't become dependent on the accessibility of the original source. The modules are usually stored, or not usually, always, after their first download by anyone using the Go proxy. The cached modules are immutable. While this applies to proxy that is operated by Google and Go team, it doesn't necessarily apply to all of them. So someone can up with their own Go proxy, but they can decide that, yeah, I will delete all of the versions and I'll replace them with malicious ones. While this could be a problem, the Go took next step to prevent it. So anytime you download a module, you would like to be sure that it's the one you intended to download. And that's what brings us to checksums. This is the GoSum file. Nobody ever opens it. It contains a lot of entries related to hashes of all the dependencies. What Go does is that it goes through the dependency tree and writes down every dependency with every version it finds. So in our case, it finds a testify package in 3 different versions. They are not all of them are used in your code. What Go does, it picks the minimal version that satisfies all of them, which is usually the highest one in the given major. In our case, the one that will be used is 1.8.1, which by the definition of semantic versioning should be backward compatible with all of them. Then we have checksums. Each entry in GoSum consists of few parts. First one of them is obvious. It's the name of the model. The second part is the version. There are 2 types of version. If you are using the module directly in your code, which is the highest version, it's only the version. Whenever you are using the Go mod, either to run your code or to resolve the dependency tree, it has a suffix /go mod. Then there is the version of hash that is being used to compute the checksum. Currently, there is only one, and Go uses SHA-256. If it becomes deprecated, or if someone decides to replace it, Go just will introduce H2, H3, and it will let us know that what hash is used. The last part is base 64 encoded hash of either Go mod or the whole module. Same as with Go mod, GoSum is modified by only 2 commands. Whenever other Go module over commands are called, this GoSum is verified, and if the checksum doesn't match with the module that is being used, the command fails. So how do we get these checksums? Whenever you download a dependency, it downloads a zip file containing the source code and the Go mod file. First, hash of Go mod file is calculated, and then the hash of zip file, which consists of hash from names of the contents and the name of the files in a deterministic order. Then those hashes are stored along the files. So new file is created and stored on a disk along these 2 files. So whenever you run any module over command, and whenever you access any module in your memory on your disk, the Go command first looks at these hashes and compares them with GoSum. This way, Go ensures that whoever ran my code after me, so whether it's my CI pipeline building the code or my colleague running the code, it makes sure that they are using the same version and identical dependency as me. The problem with this is that you cannot be sure that some virus or some misbehaving tool didn't change the dependencies on your local disk. So anyone can come, rewrite the dependency, but the hash stored on the disk will remain the same. That's why we have GoMod verify file that recomputes all the hashes, then compares them with the stored version, and if they don't match, an error is reported. Then when you run any Go command, this newly stored hash is compared with GoSum, and this way you can ensure that the dependency you downloaded and you use is exactly the one you intended to use. So now we know how to manage the dependencies, how to make sure that everyone runs the same version as me, but how can I be sure that I downloaded the right one? What if I clicked a wrong link, made a typo in a library or whatever, and downloaded some malicious version? A solution to this problem is checksum database. It's a database operated by Google, which is append only and stores all the hashes of every module ever downloaded through Go command. It's cryptographically verifiable, which means that anyone can download this list and verify on its own that it hasn't been changed or altered in any way. Same as a Go proxy, the checksum is added after first download of each module. So whenever someone releases a new version of a module or creates a new one and downloads it, its copy is stored on a Go proxy, and the checksum is stored in a checksum database. When a Go command invokes some run and wants to compare the downloaded module with GoSum entry, and the entry is missing, this entry is fetched from exactly this database. So you can be sure that not each time I download the module is, I'm sure that it's the same one, but everyone around the world downloads exactly the same module, no matter what source are they using. This way, we can download source from anywhere, whether it's official Go proxy, some third-party Go proxy, or directly the version control system. The hash we compute from the downloaded module will be compared against global checksum database, which ensures that I got the right version that I was intended to get. Nice benefit of this is that there is no developer overhead. You don't have to register your modules anywhere. It gets automatically stored whenever someone downloads your module with default Go setup, which uses Go proxy and Go checksum database. Now, let's have some real-world example. You might have noticed earlier this year that one of the more popular GitHub actions was compromised. An attacker took control of GitHub account, pushed malicious code, and retagged all the versions that were in the repository, which means that whatever version you used, the attacker made sure that you will run the malicious code. For the people that do not know how GitHub actions work, it's usually you just put some steps in your CI, and most people just use the major version like V2, or the more careful ones put the whole semantic version like 1.2.3. What the attacker did, he altered all the existing versions. So whoever ran the GitHub actions after this attack has compromised their own pipelines. Now let's see how Go protects you against these kinds of attacks. First is version pinning. So there is no version 2, there is no version range. Each dependency has its own exact version stored in the Go modules. Then each dependency that you download has its own checksum stored in a GoSum, which means that each time you download the dependency again, whether it's your colleague or your CI, you are sure that it's the same one you downloaded the first time. There is also a global checksum database, which ensures that you downloaded the right dependency in the first place. None of the operational commands that you usually run, whether you are building or running your code, change these files. So Go mode and GoSum is only your responsibility, and none of the usual command can override them. No code is executed, so you don't have to worry about some scripts running when you download the modules or build your code. And you don't have to worry about someone taking down the module. Go proxy got that covered. So once you first download the file and once you first download the module and become dependent on it, you can be sure that it will be always available and your build will succeed every time. On the top of that, Go offers its own vulnerability scanner, which scans through your code, through your dependencies, and through all of the versions, and compares them to the known vulnerability database. And whenever you are using a compromised version, you get a report from Go that you might have used a compromised code. Now, let's have a short demo. This is the project I've been working on for past couple of weeks. Sorry, let me just enter presentation mode. Okay, or not. Can you see the code? Just give me a second. Okay, so this is my program, and I came to a decision that this is no longer maintainable. I don't have the time to maintain this code, and I would like to find a library to help me with this. Lucky for me, I have found one, and it does exactly what I want. It greets the whole world on my behalf. So what do? I'll check the releases. I see that there is a version 1, which tells me that yes, this is a stable version. I can confidently use it in my software. I'll check that this version has the features I need, which is my greeter function. So I just copy the name. I go to my repository, run simple go get, which adds the module to my Go modules. Now we can see that it was added for now just as an indirect dependency because I added it via go get, but it's not yet used in my code. I got my go sum entry. So let's go to my main file and replace my function. Now, perfect. A lot of burden is now on the module developer. And now, when I run my code, I don't see the hello world. Somehow I used a wrong module that says goodbye world. Does anybody has any idea what went wrong? No, it's 1.0. We can see that. Let me run go mod tidy once again, so it become direct, but it's the right version. No, it's exactly the one we saw before. Exactly. That's right. I first came and pushed my malicious code into GitHub. Then I tagged it, and as we now know, the first download of this module stores it in a Go proxy. So now the malicious code is stored in a proxy. I can now change the code, create a new tag because it's Git. I can do whatever I want, it's mine. So GitHub has now a good version with the same tag. Now, any naive user will come, check the GitHub code. He will find that, yeah, everything is good. I'd like to use this library. So I'll just request to get this module. And instead of getting it, I get the malicious version that is stored in the Go proxy. How many of you do check that the version that was downloaded matches the version you saw on GitHub? Yeah, that's one of the solutions. Actually, this was one attack that was found this year. There was one open source repository that was about to be archived. So many people created forks. And one of these forks was exactly like this. The maintainer first pushed malicious code and then stored it in a Go proxy, then reverted back, used a regular tag, and not a single audit, not a single person revealed that they are actually pulling malicious code into their code base. Luckily for us, there is a way how to detect the difference between the version stored in a Go proxy and checksum database and the GitHub. It's this wild command, which is not that difficult. So first, we will set the target for our Go mod cache. It's a directory on the machine when all of the modules are stored. It's a shared directory between all of the projects. So if I have 5 projects, all of the modules, all of the dependencies are stored in a same repository. So I want to store the modules in some temporary directory, which then will be deleted by the system. This is pretty simple and doesn't hurt us. And then, instead of using default setting, which is official Go proxy, we set our Go proxy to direct, which means that instead of fetching the module from Go proxy, we fetch it directly from version control system, and then we run go mod download. What Go does, it downloads the zip file, downloads the Go mod, computes the hashes, and tries to compare them in the ones in a Go sum file. But they are not present, so it downloads the checksums from the official database, and it reports a mismatch. The hash Go just computed doesn't match the one that is stored in a checksum database, so you just get an alert that something went wrong. It doesn't necessarily have to be some attempt to attack or infiltrate your code. It could be just a developer trying to fix their mistakes before anyone noticed and not realizing that this is how Go modules work. Let's wrap up with one last piece of advice, which is least technical of all of them. It's a famous quote from Rob Pike. A little copying is better than a little dependency. Every time you introduce any dependency in your code base, in your software, it's not only the features and the value you are bringing in, it's all of the bugs, all of the problems, and mostly you are bringing in potentially new attack vector. Go has a very generous standard library, which can achieve a lot on its own. So whenever you are adding any dependency, please be considerate and think twice before using it. Thank you.